I'm going to show you how to use a unit circle to solve some problems. I should really say a problem. Anyway, so let t be a real number and let p equal this point. So that's a point negative square root of 3 over 2, comma, negative half. So this is negative square root of 3 over 2, but then want the negative half version. So that's this. I'm looking at this reference angle over here. Let's see where they're going with this. Be a point on the unit circle that corresponds to t. Now, if you don't know how to come up with a unit circle on your own, that's a really valuable skill to have. I will post a link in the description, or you could just look one up anywhere. Find the values of sine of t, cosine of t, and tangent t. Oh, that's easy. Okay, so the two numbers here stand for something. This one is the cosine of the angle. This one is the sine of that angle. So that answers these two parts. But tangent can be rewritten as the ratio of sine of that angle over the cosine of that angle. Right? So if sine of t is negative 1 over 2 and cosine of t is negative radical 3 over 2, well, they both have the same denominators, so shortcut is that we could just eliminate them and remain with negative 1 over negative radical 3. The negatives could cancel out because negative divided by a negative is a positive. And here's the thing that mathematicians do, and I've been doing it since high school, and I still don't really have a valuable reason why we do it, because to me this is a good answer. But we like to rationalize the denominator. So we're just going to multiply by radical 3 over radical 3. And that's going to give us a 3 on the bottom, because square root of 3 times square root of 3 is just 3. 1 times square root of 3 is just square root of 3. All right, so to me, this was a perfectly fine answer here. But hey, if your teacher likes it like that, give it to them like that. So that takes care of that. Now, here is the thing. Find arcsine of sine of 2 pi over 3. Now, it says explain your steps, show all work, do not use calculator. And it just says arcsine theta is another notation for that, right? It means exactly the same thing. Now, you may be thinking that, hey, this and this, they just kind of cancel and you remain with 2 pi over 3. Now, that wouldn't work all the time because you have to know what the domain for sine is and what the domain for, well, if you had a question with cosine, what that would be, and the domain for tangent. Now, you should definitely look this up for cosine. Well, I guess I could just tell you, if it was cosine, the domain for cosine are in these two quadrants, and the domain for sine are in these two quadrants. Why that's the case, that's another really, well, I don't want to say valuable, but that's a really good thing to know. But for now, just take it as is, because this is a video made just like to practice for a test. So anyway, so this is the domain. But this angle, 2 pi over 3, is out here. That's this angle right here. So we're looking at this reference angle. So what do? Well, what you have to do is look for the reference angle in the correct quadrant here. How do you know which one's the correct quadrant? Let me just erase all these things since that deals with the previous problem. But how do you know which one is the correct quadrant? Well, in this quadrant where the angle is sine positive or negative? Well, we have this little acronym, all students take calculus, that will show you where things are positive or negative. Or you can just look at it, right? The sine is always positive in this quadrant, but that's what the S stands for. Sine is always positive here. T, tangent is always positive here. Everything, all are positive here. Cosines, which are the first ones, are positive in this quadrant. So, since it's positive here, which one of these quadrants would I want to make my reference angle in? Well, not this one because sine is negative here. So I'm going to do it in the one where it is positive. And that's the same angle as this one. Right? So that's really like saying, what is the, it's kind of like saying what is the inverse sine of the sine of pi over 3, because that's the new angle, pi over 3. Now you could kind of cancel them out and you just get the pi over 3. All right, so that's the answer for that. And you'll do a similar thing for tangent or cosine. The domain for tangent is the same thing as sine. The domain for cosine is in these two quadrants.